Hi, I'm Marissa Rohrig. I'm a mine safety and health instructor with Michigan Tech University. I'm based out of Grand Rapids, Michigan, and I teach surface MSHA safety classes throughout the state. I'm up in Greenland, Michigan this week doing some underground training with Matthew Portfleet. Matt's actually the director of mine safety and health at Michigan Tech, and he owns and operates the Adventure Mining Company. He also teaches university classes in drilling and blasting and mine safety, and fun fact, he designs and constructs bat habitat-friendly abandoned mine enclosures in cooperation with the U.S. Forest Service and the Department of Natural Resources. So, he's basically Batman. We are also working this week with Bob Barron. He's a former tech professor and just general wild man. He is a world-renowned copper country mineral expert and collector. Another fun fact about Bob is that he found a 17-ton copper boulder at the bottom of Lake Superior. And with the help of the U.S. Army Corps of Engineers and the state of Michigan, they recovered it, and it now rests at the Seaman Mineral Museum on MTU's campus. We are doing this demo at the Adventure Mine. The Adventure Mine is a copper mine near Greenland, Michigan that operated from 1850 to 1920. During that time, miners removed more than 11 million pounds of native copper from the ground. Since 2004, the Adventure Mining Company has offered a variety of historic underground mine tours and mining educational workshops. Today, there is probably more copper and silver in the mine than has been mined out in all the preceding years. So what we're going to do is we're actually going to blast a section of the mine wall in search of that copper, silver, or anything that looks geologically interesting. Basically, we will on a small scale demo the mining process. We're going to include rock scaling, drilling, blasting, and mucking. Manual rock scaling is the act of removing unstable or potentially unstable rock by using hand tools. It's basically the safe removal of unstable rock. Mining processes actively create unstable environments, whether that be high walls at surface mines or tunnels, shafts, and rooms of underground mines. Scaling and barring is the process of removing rock before it could potentially fall and cause injury. We are scaling and barring in the area directly above where we are going to move next to do drilling and then eventually blasting. We just want to ensure that the area where we are doing the drilling is safe and that essentially no rock will fall on our head while we're doing the next task. Scaling is a task that requires extensive training and experience before it can be done safely. It takes time to recognize dangerous conditions, such as cracks in the rock, different sounds the rock barring will produce, geological structures of the area, and just general I know what I'm doing experience. To develop these skills, you should work in conjunction with an experienced miner for as long as it takes to become fully competent. Rock scaling is a crucial part of maintaining a safe work environment, not only for your own cranium, but the beautiful noggins of everyone else working at your site. Since this is my first time, I'm working under the guidance of Matt the entire time. He picked an area for me to work on and he's coaching me through it. What may seem like a quick scaling experience that you're watching here in this video actually took me more than 15 minutes to remove all those rocks. And even though it may not look that difficult, I worked up quite a sweat. Even though the actual internal temperature of the mine is only about 48 degrees. Next, we're going to set up to do some rock drilling. We are doing this to create holes in the rocks where we will place explosives for blasting. Drilling holes may also be performed to install ground control measures, for example, roof bolting, ground monitoring devices, and other applications. Roof bolting, by the way, refers to metal rods that are inserted into a mine roof to prevent a roof collapse. We'll talk drill details in a minute, but the drill is powered by pneumatics or compressed air. So before we get to that point, we should do a brief overview of just airline safety, and Matt will be giving us some more info on this.
In the Adventure Mine, we're using a 185 CFM diesel-powered air compressor located outside of our mine. The main air system components we have are a 1-inch airline running inside to our drilling location, a shutoff valve located near our work area, and an airline oiler provides lubrication to our rock drill. We also have a short length of smaller 3/4-inch airline that connects to our drill, which is just a heck of a lot easier to move around the mine while we're working. The main hazard we have here is with the pressurized airline. Our compressor is about 60 horsepower, so if you can imagine a severed or uncoupled airline with 60 horsepower worth of energy coming out the end of it, you're going to have it whipping and thrashing around the area with very dangerous force, creating a deadly hazard. As you can see in the video, while Marissa is securely holding the airline, while we blow out these lines to clear them of any possible dirt or debris or moisture inside, there's a tremendous amount of force of air exiting a line. A good friend of mine once told me a story from when he worked at Centennial Copper Mine, a little bit north of Calumet, Michigan, about having an airline break while we were drilling at end of a new drift. So basically drilling a dead-end tunnel underground. He and his coworker literally sat there for a couple hours after the airline broke and whipped around the tunnel, having no way to get past the airline to get to a shutoff valve. It wasn't until a coworker finally walked by and saw a broken airline and shut the air off that they were finally able to exit their drift. So it's going to be a very serious situation. To prevent this, we have these short cables called whip checks. These whip checks secure the airline couplers to each other in case of a failure, along with pins or wires ties and some types of couplers also. These are an EMSA regulation for all airlines and also an OSHA regulation for construction site jackhammer and similar air tools and airlines. These definitely need to be checked daily as part of your pre-shift work exam. We also have a shutoff valve located near our work area so we can move our drill around safely, and also in case something should go wrong while drilling, we shut the air off quickly. In 2014, at a mine in Nevada, a jackleg drill operator had his sweatshirt hood become entangled in a drill steel. He couldn't reach any air shutoff valves, and because he was working alone, there was nobody else nearby to help him, and tragically he suffocated and died. For that reason, it is also an EMSA regulation that there are always two people in the active mining area, so someone is always available to quickly shut off the air in case of an emergency.
We start high and work low?
Yeah, we can start high and do that. That's great. Okay, air on.
Air on.
Yep.
While a rock drill may be as simple as a specialized form of a chisel, it may also take the form of a powered machine. The mechanism may be worked or powered by hand, by steam, by compressed air called pneumatics, by hydraulics, or by electricity. Machine rock drills come in two basic forms: those that operate by percussion, which is using a reciprocating motion, and those that are abrasive, which means they use a rotary motion. A smaller, handheld percussion rock drill is considered to be a type of jackhammer. Drilling can be done with single operator drills like the one we're using or large multi-drill rigs. Today, we're using a jackleg pneumatic rock drill. That means it's a jackhammer on a mounted air cylinder which assists to push the drill into the rock. The drill operates by percussion.
So we'll drill steels apart the long steel shaft. They come in various lengths. This is a tapered bit. 11-degree tapers in the US, 12 degrees tapers in Canada. No idea why. Bits just fit on there. And then you hit them on a rock. And usually we'll hold them well enough to get started. Then when the drill hammers, it hammers them on. So this is a 4-foot steel. We'll drill a hole in there.
So this is a task that requires hearing protection. Actually, in some situations, it may be a task that requires dual hearing protection. 30 CFR Part 62 has 85 decibels as the action level, 90 decibels as the threshold for the beginning of permissible exposure limits, and 105 as the threshold for dual hearing protection. We were running this drill at about 100 to 105 decibels, but we only spent about an hour with the drill in total. So we were within what it is considered acceptable to get those two holes in place to begin blasting.
See, with this stuff, you push this little tab in. They used to have a twist cap on it, but evidently people would forget to do that, like me. And they changed to this thing. So you push that in, and now it's lined up to take an electrical charge. Now, the thing we got to do is get that in all the way to the back. So there's space, and then you can back.
Blasting is the process of breaking rock with the use of explosives. These explosives are loaded into the pre-drilled holes and then detonated. The holes we drilled are 4 feet deep, and we will be using Autostem as our quote-unquote explosive. While there are many types of explosives and blast initiation devices available, Each with their own unique properties and, say it with me, training requirements, Autostem is actually a non-detonating rock blasting agent. Non-detonating means it has a relatively low speed of reaction or burn rate compared to traditional high explosives, but when confined in a drill hole, has more gas energy or rock heaving power to break the rock and displace it. It's extremely safe. It actually gets delivered to us by UPS and it won't detonate unless it's confined. It comes in a variety of prepackaged sizes for different uses, and it's the primary blasting agent that we use at this mine. Lastly, it's called Autostem as the cartridges don't require traditional stemming, which would be placing clay or crushed rock after the charges to contain the gas pressure. These cartridges have a unique design that performs that function automatically.
So we're charging the capacitors in the blast machine here. Waiting for the light to go steady. Light is steady. 3, 2, 1, fire in the hole.
Realistically,
So now we are just going to test it. This is a blaster's multimeter or galvanometer.
Okay.
Turn on first until it cycles on.
And it's showing you that they make
And
full
the fact
connection.
that it's vibrating, it's got a reading there. It's showing us that is a complete circuit.
Cool.
So that one's good. Let's drop that way.
basically you're just checking for continuity and make sure we didn't break something.
So they will work.
Yep.
Or should work.
And really, there's no, it's plasters, everybody's different. You can do them white to white, green to white, as long as you do it consistently and have some way you're doing them. Now these two, these two should test good still, which they do.
And that's just a little thing you put in there in case you ever pull it for any reason, it's not going to undo, as you're stringing your wire out. So you just put those little ears in there and wrap it together.
Makes sense.
Yep, that orange spool. So this is our lead line then, so it's a cheap wire. So this is what goes to the blastometer. We call it shunted, it's twisted together. That way we can check this wire, which is nicely beat up. Actually, I probably can just do it with this. Yeah, there's nothing on there. So we're going to test it again. Oops. Stay on. So this wire is good. It means the wire is continuous. So this will go to the. Probably having the two greens.
Right, throw them down.
One's over there to your right.
I thought we were gonna.
That we hang some places so it's not in the water, so it's not shorting out.
As we finish staging the Autostem, let's go over some blasting safety. You want to make sure that you have a safe location to initiate the blast. In our situation here at the Adventure Mine, we are in a crosscut a distance away from the stope in which we are blasting. You should always verify that everybody at the mine is accounted for and is aware that a blast is taking place. Always do a final circuit check, if possible, just before blasting. Have posted signs or barricades and trained personnel at all entry points to the blast area. Have a designated warning alert or system that warns all miners about the blast. This could be in the form of sirens or updates or alerts to miners' radios or cell phones.
Okay, this is our blasting tester here.
Well, I hope it does something.
Yep. So when it's your turn to do this, there's two buttons. One is arm. You press the arm, you hold it down until the light starts flashing. So it's a 2-button detonation. Once it's steady like that, then you press second button and it will go boom a second later. Brandon, we are blasting.
All right.
Okay,
Then you got to really count down like 3, 2, 1, fire in a hole, press the button.
before I hit fire.
Yep.
Okay, so I'm going to arm it first.
Yep. And then go 3, 2, 1, fire.
It toggles back.
Flashing.
Until it starts flashing.
Okay, Brandon, a couple seconds here. Bruce is going to count down.
All right, 3, 2, 1, fire in the hole.
Yeah, I had mine in. How about you? You have young ears.
I should have had it on.
You got another 500 explosions.
I don't think it helps.
Oh, wow.
Well, we should always wait for it to clear out. We're going to go carefully and see what we can see from a distance before we go charging in there. Mainly look for fly rock. I didn't hear anything over here at all.
No, I didn't. I didn't hear a lot of rock in general.
No.
After blasting, the area must be allowed time to clear of blast fumes. We actually waited 24 hours before we re-entered the stope to do our post-blast inspection.
So as you walk into this area after we blasted, we can see lots of fresh rock on the ground here. This is where we need to be really careful, really aware of our surroundings, kind of situational awareness. That fly rock came with extreme force from that face. It may have impacted above us on the side walls, the hanging wall. You gotta take a second here and look around, make sure there's no impact zones, make sure nothing we see new scars. You can tell the new impacts, you see a clean spot or a dry spot where it impacted. So I don't see anything like that right now, so we're pretty safe right here. I do see some impacts way over there. We're not going in and out, so that's fine. We're gonna walk up here and it's gonna be very observant, kind of seeing what's on the ground here, seeing what we need to address. Most of this looks pretty stable.
So as you walk up to the face, we're going to be visually looking for hazards, but also scaling the rock with a scaling bar as we go. Solid, safe rock will have a sharp ring to it when struck with a bar, compared to loose areas that have more of a dull thud. One very important part of this process is always make sure we have an escape route. Find easy ways or places to be able to step back quickly in case the rock falls where we're not expecting it. We'll go through and look at this area first, look for obvious hazards, eliminate those, and then before we drill in the future, we'll inspect the area again to make sure we can work there safely.
Fly rock, ejected from the blast, can damage other parts of the mine, creating hazards a substantial distance away from the blast area. You should always take great care to maintain situational awareness during the inspection of the post-blast area. Typically, scaling is going to be required, working from a safe area and progressing the recently blasted area.
So at this point, we're pretty good to at least be here for a minute. We got most of the hazards taken care of. Before we drill, we'll definitely go back on top, check all that, make sure it's safe. But I feel pretty confident right now that we can be in the muck pile, take a look around, see what we found, and have some fun.
Mucking is the removal of the recently blasted material from the mine. It could be ore, waste rock, or both. This should only be performed after the post-blast inspection is complete. In some cases, ground support, like roof bolts, would be installed before mucking, during partially completed mucking, or after the mucking process is complete, all depending on the geological structure of the ore body. Mucking is performed either by hand or with a variety of equipment types, depending on the mine. In the case of the Adventure Mine, today we're looking for copper and silver mineral specimens, so it's mostly hand mucking. Later, after several small blasts, we will bring in a loader and clear out some of that waste rock.
The rock that we're drilling here is referred to as amygdaloidal basalt. It's a volcanic rock that erupted on the surface of the earth and rapidly cooled, leaving a rock filled with lots of air bubbles and fissures. Much later in time, these air pockets were filled with copper, silver, quartz, and other minerals that create a mineable ore body here in the Keweenaw. This area, the Keweenaw Peninsula, is geologically unique, not because we find native copper, but because of the sheer immense quantity of native copper that occurred here. This is the only place in the entire world where mineable quantities of native copper occurred.
Mining is, by definition, the process of extracting useful minerals from the earth. In this video, we did a small-scale demonstration of the underground mining process. In the United States, less than 6% of mining operations are actually underground. The vast majority of our mineral extraction happens at surface mines, with 44% of our mining operations producing the primary commodity of sand and gravel. In most surface mining operations, the mining process consists of the same unit operations: drilling, blasting, mucking, otherwise known as loading, and hauling. Mining provides the raw materials required for nearly every industry and consumer product, feeding our manufacturing, defense, medical, and energy supply chains. Although in Michigan we are no longer actively mining copper in the same quantities as we did 100 years ago, we are mining other valuable minerals. In Michigan, our mines produce iron ore, cobalt, nickel, stone like limestone, sand and gravel, salt, cement, clay and shale, gypsum, and peat. We have approximately 457 active mines in our state. Together, we produced over $2.6 billion in product in 2021, making us 10th in the nation for non-fuel mineral production.